Hi there, folks. Today we're looking at variance and standard deviation. And variance and standard deviation are just a couple more measurements of dispersion that we have here. They're measuring how spread out the data is. Okay, and when we think about other measures of dispersion, we have like the range of the data shows us the distance from the highest to the lowest values. So they're showing us which values are kind of covered here, or the distance of values that are covered. You might also remember like the interquartile range looks at the range of the first and the third quartiles. And again, it's measuring how spread out the data is that way. Even box and whisker plots are a representation of how spread out the data is and how clustered together certain pieces of the data might be. Variance and standard deviation also measure how spread out the data is. They're a measure of dispersion. Okay. Unlike the rest of these, though, instead of measuring extremes here from one extreme to the other in terms of something like the range, what variance and standard deviation do, and really the standard deviation is the one that we typically use, but it kind of measures how spread out the data is, moving kind of from the center of the data. All right, and really it's measuring from the mean of the data. And so that's what standard deviation kind of does. We're measuring how spread out the data is, but just from a different perspective. Instead of measuring how spread it out it is based on like highest and lowest, we kind of go to the middle of the data, the average, the mean of the data, and we measure how spread out the data is from that mean value, okay? So we kind of start from the inside out when we're measuring how spread out the data is using something like standard deviation. So again, it's still measuring how spread out the data is, but instead of measuring it from extremes, we're measuring it from the average, okay? And so here's the formulas for these guys. They look very complicated, but once you understand the different components here, they're actually very easy. They're just a little bit tedious when we go to do these by hand, okay? So the variance here, and you'll... before we kind of get into this, look at the variance and standard deviation formulas. Hopefully you realize that they're basically the same formula, except the standard deviation, we take the square root. And really, if you take this variance formula, watch this, I'm going to take the square root of each side, and what I get is the standard deviation, okay? And that little value that's here, this is sigma, that's lowercase sigma. We remember its big brother from summations. But the variance, that's sigma squared equals. And when we kind of read this thing, here's what each of these data values represent. So the x with the bar of it, we already know that's the mean. But then this idea of x1, x2, x3, x4, all the way to x sub n, all right, those represent the actual data values. In other words, what it's doing here is we're saying, hey, the data value minus the mean and square it. Plus the next data value minus the mean and square it. Plus the next data value minus the mean and square it. And we keep doing that until we essentially just run out of data values, okay? Then we divide by n minus 1, which n is the number of data values, okay? So if there are 10 data values, I'm going to divide by 9, okay? And that n minus 1, this is the formula for when we're looking at the sample, okay? So this is the variance and standard deviation when we're looking at a sample of values. If we were looking at the entire population, all right, if we're looking at the entire population, basically the only difference in the formula is this becomes an n down here instead of an n minus 1, okay? And you'll see each of those things as we kind of move through. Eventually, when we kind of do this stuff on the calculator, you'll see the population variance and standard deviation, and you'll also see the sample variance and standard deviation. We're going to stick with the sample here, so using the n minus 1, just because most of the time, that's what we're looking at. We're looking at samples, and so these are the formulas that we're going to use, okay? And so again, just to reiterate this, x with the bar over it is the mean, x sub n, or like x sub 1, x sub 2, x sub 3, those are each of the data values that we have, and n is the number of data values we have, okay? So again, it's data value minus the mean and square it, plus the next data value minus the mean and square it, plus the next one minus the mean and square it, and we just keep doing that until essentially we've run out of data values, okay? We divide that by n minus 1, by the number of data values minus 1. That gives us our variance, and then we take the square root to get the standard deviation, okay? And so here's what this thing looks like. If we look at something like this guy, it says find the variance and standard deviation. We've already looked at this data set once before, All right, and so we've already found the mean of this thing, so I'm just going to write the mean down, so x with the bar over it. So the mean, if we add them all up and divide by how many we have, that's 122, okay? And we calculated that in a previous example, so there's the mean. You can go calculate it again if you need to. But in terms of the variance standard deviation, I really just need the mean. I need each of the data values, which I already have. I can see all the data values written down right here. And I need how many data values there are. Well, that's pretty easy to find too. It's 8, okay? And so when I look at this, I have everything I need to find the variance and standard deviation already, okay? And so here we go, the variance, just sigma squared. And when I do this, I just take the first data value minus the mean and square it. So I do 1 over 4 minus the 122, and I square it. And then I do the same thing with the next data value. So plus the next data value, 117 minus the mean, and square it. Plus the next data value minus the mean, and square it. Plus the next data value minus the mean, and square it. And I just kind of go through and do every single one of these. Whew, I just had enough space for that. We can shorten this up a little bit if we want to. We could look at this and say, hey, 3 of these data values are the same. So instead of writing all 3 of those out, I could just multiply one of these by 3 and then get rid of the other ones, okay? I could do the same thing with any repeated values. So look for those kind of things. Those are just some of the little shortcuts that we can use when we're doing this, okay? And now I'm going to divide that by n minus 1. So there are 8 data values, so 8 minus 1. And now from here, it just becomes a job kind of for my calculator. And so I just go over and plug this thing to my calculator. I do the 104 minus the 122, and I get a negative 18, and I square it, and I get a 324. And then I do the next one, the 117. And this one you could probably do without the calculator. 117 minus the 122 is a negative 5. Negative 5 squared is a 25. The next one, it's a 104 again, so I'm going to get the same thing as I did before, the 324. The next one, 136 minus 122 is a 14. 14 squared is a 196. The next one, maybe you want to let the calculator do this one. 189 minus the 122 is a 67. And now I want to square that. That gives me a 44,089. The next one, the 109. 109 minus a 122 is a negative 13. Negative 13 squared is a 169. 113 minus a 122 is a negative 9. Negative 9 squared is a positive 81. And then another 104 is going to give me another 324. Okay? And then that's all over 8 minus 1, which is the 7. And again, this is a job for my calculator. I just plug this in, the 324 plus the 25 plus another 324. And again, if you had condensed those 324s, it kind of would shorten this up just a little bit. Hopefully I hit all the right buttons here. And so I get 5,932. And I'm just going to divide that by 7. And so I get 847.43. So that's my variance, 847.43, if I remember correctly. And now to find the standard deviation, I do all that same stuff, and I just take the square root. So I'm just going to take the square root of this value. Again, right here in my calculator, the square root of the previous answer. And I get a 29.11 here. And so that's my variance and standard deviation. Again, when I look at that standard deviation, it's basically saying that if I start at the mean and start going out in increments of 29.11, I should encounter a certain number of data values, a certain number of my data values. That's kind of what we're measuring. We're measuring how spread out this is from the mean. And it takes a certain number of standard deviations in order to collect all of my data values. So that 29.11, it's kind of measuring how far spread out this thing is from the mean. So from that 122, how spread out is this data? How far do I have to go in order to collect all my data values in certain increments, okay?